Hi everybody. What I'm going to do today is I'm going to show you how to apply a PSPICE to do a full adder circuit or digital circuit, which I'm going to use both PSPICE and also ADDER for the design. So the goal of the video of this one is that I'm going to how to use the circuit and compare to whatever that you decide. For this one, for the full adder circuit, you have input, C input, A and B, and output. Usually when you add two digits number, for example A and B, and you can see that it's going to have like 0 plus 0. That means you have sum to be 0, right? And then carry out is going to be okay, let's do this way then. To see or better understand okay, sorry about that. Maybe we have to start over again. So you have 2 bits, so the logic combination is going to be have like 4, right? Just copy this one. So totally you're going to have what it is. Okay, so this is that's we call our half adder our circuit. So you have A to be 0 0 and 1 1, and then B 0 1 0 1. For the sum 0 plus 0 you got 0. 0 and 1 you have 1, right? This is for the sum. 1 plus 0 is equal to 1, and 1 plus 1 is equal to 0. And for the carry out, what you have is that 0 and 0 you have 0, right? 0 1 you still have 0. 1 0 you still have 0, but 1 plus 1 you can have carry out to be 1. Okay. And what I have just right here is just you have, let's cue this guy out. Okay. And you have 3 inputs, Cn, A, B. So 0 plus 0s and 0. This is like full adder circuit. You have sum to be 0, you have carry out 0. Let's take a look for this example right here. 1 plus 1 plus 1, you have sum to be 0, but your carry out is the 1, right? So whatever you decide in the full adder circuit, it doesn't matter what you're going to use, the exclusive or AND gate, NAND gate, or gate. You're going to have to correspond to the truth table of your full adder circuit. Okay, if you go through your Google, you can see your digital full adder circuit. Let's go to image. You can see it's going to be many full adder circuits. It's kind of like a little bit slow. Oops, sorry. Okay, just let's go through the circuit then. We are going to start design the circuit. I'm going to compare to the simulation from PSPICE and also from our ADDER. Looking forward, we're going to NAND gate. Okay, so here you can have like this is full adder circuit, right? You have two exclusive OR, and then two AND gate and also one OR gate. That can vary. And or you can just simply apply this one if you want to. Okay, so let's follow this one. You need two exclusive OR gates, 2 AND gate, and 1 OR gate. Okay, so to look better, I'm gonna keep that one open. Now for PSPICE, you're looking for circuit, you get new part, right? And you are looking for, I still don't remember, what's the number of your IC that's give you different type of gates. So what I'm going to do, I'm going to this one and hit the down arrow to look for let's see. Okay, this is our 7409. I need 2 of them. That's their AND gate. 7409. So Control G, get new part. I'm start from there. Now let's see if we can see here to input OR gate. Okay, here is the exclusive OR. And we come back later, so maybe we can get better, like I'll just pick this one up first. 74136. I need 2 of them, so just left click, and right click to stop. Now let's find to input OR gate. Okay, hopefully it's coming up. That's the NOR gate. So okay, here we go. 7432. I'll place that one. I need only one, right? Left click to place and right click to stop. Somehow I find out that when you pick up a certain type of gate but different number, some numbers work better than some number because somehow they have too much delay and it gives you unclear output. You will see. Hopefully it's not gonna happen. So let's draw the circuit then. You have redraw the circuit here. You put there to input OR gate. Okay, let's make connection. So you could like control the video. And then right here. Next, let move this guy down here. And let's move this guy down here. It's better. Control the open view to do the wiring diagram. So this one going to be your sum output. Control W. So you have this one. Go to pin number 2 of 7409, and you also take the output of our US3 exclusive OR gate, this guy, to pin number 1 of U1A, which is the AND gate, correct? And this one is going to be your, your carry out. So I simply have a problem with this one. So go to attribute. Oops, sorry. Supposed to be label, and that's to be carry out. Alright. Let's blow this up a little bit, and this one also I need to label is that the sum, right? Okay. Now let's continue to draw the circuit. Control W to do the wiring again. Okay, just put this right here. For A input and B input, you take A input to go down to pin number 1 up U2A. It doesn't matter, you can connect to the pin number 2 of U2A. Simply just logic. And then for the input B, you go to down to the pin number 2 of U2A. Okay. So what you need is that you need to get the digital signal, the input digital signal, right, to the gate. So what I need, they have the part that we call DG clock. Let's see right here. Alright, you place, so you look for 3 of them. Okay, and then I select all of this input and then Ctrl R to rotate, and then I move up there just to manage to be input. So let's change this one just not to be confused. Change this one to be CIN, right? That's one input. As you can see here, you have CIN as input and also A and B. So let's change this one from DSTM2 to be the input A, and also the STM3, you go to oops, somehow what happened, this label is not enabled, so what's wrong? Let's try again. Oops, I don't know what's wrong. Well, just kill this guy then and copy this one. Control C, Control V. Let's see, we can change this. I'll go to Edit, Attribute, Left Frame Designer. Okay, we can just put B just right here. Now you have 3 input. So let's go to make connection. Control W. Oops. See. Sorry guys. Okay, I just need to log in. Re-log in. And now you go to the circuit. Where's my circuit? I was at the Google, right? Oh. Hold on a second. 3-1. Okay, doesn't matter. Search that again. It's supposed to be go to full adder. Second. My computer is kind of slow. Full adder circuit. Okay. And you look for image. And we're going to pick up one full adder digital circuit. Yeah, you have this one. Okay, so let's move this a little bit. Or let's zoom out. Always have some problem here. Okay. This is the circuit that we are going to use. So the next step is let finish do the wiring. This is your in. It's going to go to pin number 1, number 2, or pin number 2, sorry, of U4A and U1A. And for the clock, A is going to pin number 2 or P2A, right? And then you have to finish. What about B? Oops, I think I did wrong. So undo it. Control W, right? A, actually I did it great. And B is get into this guy. Pin number 2 or U3A. Alright, so you finish all of them. Make sure you got right. Okay. So oops. So we're missing pin number 1 of U2A, right? They're supposed to go to from the output of exclusive OR. I did. Oh, I mean this is the first exclusive OR U3A. So let's go to input A, right? So that's what we need. Kind of confused here. This is A, right? But let's take a look at this guy. Pin number 1 of U2A. So let's go to the input B, right? Okay. So let's complete this one. Alright. Now for the simulation, you need to set up the digital logic of your C input A and B, or the period. So you need to go back to your truth table. You take a look at the input. Let's see here. Each logic combination is take 1 second. So you have total like 18 seconds. That's the 16 second. 1, 2, 3 to 16 seconds. So this is one period of your. Sorry, this is a 2 period of your CIN. And then if you want to set up your digital clock, that means you have to turn off input CIN is there becomes 0 for 4 seconds, and you have logic 1 to be another 4 seconds, and you need 2 periods to complete the total logic combination. Or what I mean is that you have like 16 logic combinations. Now let's go back to your circuit. So you start with CN first. You go to edit. You go to attribute. So your on time is going to be 4 seconds, right? You set attribute. Your off time also going to be 4 seconds. So you're done. Now for your A, you go to the truth table. You can see that it's going to be off time 2 seconds, on time 2 seconds, and the period is become 4 seconds. Let's go back to our circuit. So you go to input A, you go to attribute. So your on time here is going to be 2 seconds, right? You don't need to put S over there. And then another 2 seconds. Click OK. And you go to B, you go to attribute, and you go to the truth table. You can see that B is on off time going to be 0 for 1 second and 1 for 1 second, and the period is going to be like 2 seconds. Now you go to on time. This one is going to be 1. You set attribute. You go to off time, also another 1 second. 1 second, sorry. So you complete your circuit, and also you set up your digital clock for the input CAN, A and B, and you already have output as the sum and carry out. The next step you need to do, need to go to setup. You go to the menu or analysis. You go to setup. You need to pick up a transient. The final time you want to see the whole period. For the total combination, you have like 16 here, right? You can just simply do the final time for 16 seconds. So let's put this one to be 20 seconds then. Final time. The print step, you don't need to care about that. Click OK. And now let's save as the I put as the digital. I have full ADDER. I'm not sure it's gonna be overwrite the previous file, not so I put new. Now let's take a look quick. Do our simulation, right? Okay, you have the plot pop up. I just want to check the input first. You go to icon of your trace. Let's start with the CN1. As you can see, this is the for is it 8? Yeah, 8 seconds, right? So CN start the input CN is start from logic 0 for 4 seconds, and then jump to the logic 1 for another 4 seconds. So this is, you have one period which is the 8 seconds for the input CAN. Now take a look at their input A. Somehow some problem here, I don't understand. Let's clear this one out. You go to label A1 and you delete. Let's try B to see if we have some problem or not. I also have some problem, I don't understand. Okay, let's correct this one. What's wrong then? This one we simply plot 3 inputs, A, B, and C. What happened? Go to attribute again. You have on time to be 2 seconds. You have off time to be 2 seconds. I cancel out. Let's cut this guy out to see. No. Oh, okay. Control X. And do simulation again. Oops. Floating. So it's not allowed because you need to connect to some device. Let's get that back to our Control Z, right? Undo. I still don't understand why. Let's go to our split. Why it show some weird input for CN1 input seem to work out right. See? Now let's take a look at the input digital clock. Let's see if we have another option. You go to the plot. So you have our U3A. Go to input pin 1 of U3A and pin 2 of U3A as the input A and B, right? So let's see if we have another option. I can see right here U1A of A. Okay, let's try. See, still have some problem. And for B, click this one because you start having. Oh, B is no, not this one. So let's go to the input B then. Also have some problem here. Let's put A. If you have problem with your input, of course, definitely you're gonna have also have problem with your output sum and carry out as well. So let's make the decision. This is what happened here. Okay, I'll stop here for a second, so I will come back with the solution. Okay, sorry, finally I found it out. So similar for U to A. You notice this one is take both input from B and also from A. It's my mistake, very sorry about it. So actually we're going to take input for U to A is going to take input from A only, so you don't have this one. Correct? And let's check this one out. For A, you supply to input. Actually one input, but here I have two input. 1 and 2. What about? Oh, okay, sorry. It's just like a little bit confused. Right. And also I supply the input to U3A, pin number 1, right here, for the input A. Let's check this one out. It's too big, I have some problem. Okay, we still have time then. Now you go to what? Go to simulation, and let's see the plot again. You go to input CN1. You go to your input A and B address. So you go A. Now it's working fine, right? You go to trace, address. Now you look for B. Alright. So this followed your truth table. As you have the 3 inputs. Dash CIN, you have the period of X seconds, right? For A, you have the period of 4. And then for B, you have the period of 2. So that's how you get your input. This is the C input. You have the period of X seconds. You have on or 0, logic 0 for 4 seconds, and logic 1 for 4 seconds. And for A, you have logic 0 for 4 seconds. Logic 1 to be 4 seconds. And for B, it's take only 2 seconds for logic 0. And then take another 2 seconds for logic 1. And let's see your output. I'm not sure it's going to work or not. You have output sum and carry, right? Let's take a look at this one. Yeah, you have some problem because, as I mentioned earlier, that your some exclusive or logic, some numbers doesn't work, perfectly. So you might need to change your logic gate. But you can follow this one. The main point is that the video will show you how to set up your clock as their input. In this case, it's our CAN and A and B. Okay, and next video I'm going to show you how to apply your PSPICE to do full adder circuit simulation. Okay, let's try another number then. Look for exclusive or Control G. Just want to see if they are another number of exclusive, or just to make sure that this is like 3 input OR gate. This one for 2 input OR gate. Maybe you have only one number here. We have our 74x6. Let's see if we change this one. Let's kill this guy. Delete. Let's replace this guy into the circuit. Meaning the IC number 74x6 for the exclusive OR. And do the simulate again. Let's go to where you see output sum. Okay, so it's worked. Just replace your exclusive OR by the new IC number 74x6. And now let's take a look at what your output see carry out. That's worked nice. So that means we need to go back to maybe change the new number of IC for AND gate and OR gate. Let's see if we still have this. Should be okay. Let's continue to finish this then. Let's change this one to input OR gate first. Let's look for the new number then. To input OR gate. See if still have another new IC number or not. Need to go back. 737432. The same number. Okay, let's continue our searching. This may have some difficulty, to look for the new IC number. That's exclusive OR. That's 3 input AND gate. 7408. This one I used 7409. I'm wondering if we can use this one instead of our 7409. Okay. Let's replace this one. Shift and shift. Delete and replace that 7409 with 7407 or 8, sorry. And I want to check this output. Let's put something right here as the test. I just want to see where the signal starting has some problem. So you go to simulate. Okay, let's see the plot. You just go to see carry out. Okay, now it's working fine. Just because you used the 74 to input AND gate instead of 7409. Okay, now let's go to check your output. Let's start over again then. You go to start from 3 input first. Start from CAN, and you go to A, and you go to B, and now it's going to be your output. Let's start with sum, and you go to your output carry out, and then you can compare to your truth table. Let's try this style. You can also enable the cursor here, and this is your truth table. Okay, let's check this out. For the output sum, 0 0 0 1 to see if sum become 1 or not. See, you can see when you enable cursor, it can show you obviously the logic status of each input and output. So let's look for the input 0 0 1. Okay, or 0 0 0. You can see your sum is equal to 0, right? This is your sum. The logic is 0. And if you go to this guy 0 0 1, your sum has to be 1. 0 0 1. See, your sum has to be 1, and your carry out to be 0. You can check this out. So that means that your circuit is correct for your design. So that's all I need to talk about. That's what. Have a little bit problem about the gate or IC number that we used for the full adder digital circuit. So you need to do some change of your circuit IC. I mean, replaced by the new IC number. Okay. The next video is going to be use the PSPICE 4 for designing our full adder digital circuit. Okay.